Very good morning and warm greetings to everyone. Today we are going to see about the overhanging beam, especially the single overhanging beam. The case of single overhanging beam, how will you find the shear force and bending moment, and how to draw the SFD and BMD. You know that single overhanging beam, for example, I am taking this as a beam. So here left side, so this is one support. This portion is an overhanging portion. Another support is here, right? So you're having an overhanging span to the left hand side of support A. This is support B, and this portion is 1 meter, and this portion is 4 meter. It is loaded with the point load at the left overhanging portion, and the portion, this support portion, you have an UDL of 5 kilonewton per meter run. So above that we are having an 5 kilonewton per meter run, and the total span is 5 meter. So overhanging portion is 1 meter, and between the support you have 4 meters. So how will you find the shear force for this one side overhanging beam, which is of left hand overhanging beam? So here a point load of downward point load of say 10 kilonewton is acting. 10 kilonewton is acting, and in between the support 5 kilonewton per meter for a span of 4 meters. So that is the case. Now what will happen? Whatever the total load, so due to UDL, so 5 into 4, 20 kilonewton. So here 10 kilonewton downward. So 20 plus 10, 30 kilonewton is acting on the total span of the beam of 5 meter. 1 meter overhanging portion, 4 meter between the two support. I call this AB and this portion as C. Right, between A and C, right, you have only one point load, downward point load of 10 kilonewton. So now what will be the reaction at this point, say support B? To find the support reaction at B, I am taking moment about due to the external load and reaction about the point B. So due to an UDL, what is the load? Anti-clockwise moment. So minus 5 into 4, 20. So minus 20 kilonewton, and here again a downward load of whatever 10, so 30 kilonewton. But you know that, right, moment due to this 10 kilonewton is 10 into 5, 50 kilonewton meter. So due to UDL, right, 5 into 4 square by 2, that means 5 into 4, 20, 20 into 4 by 2 is 2, 20 into 2, 40 kilonewton meter. So due to this, right, point load 40 kilonewton anti-clockwise moment due to UDL, again you have 5 into 4 into 4 by 2, 20 into 2, 40 kilonewton meter. So totally here 40 kilonewton meter, 40 kilonewton due to UDL. You know that moment due to this reaction RA into 4, that is a clockwise moment. RA into 4, right, minus 40 kilonewton meter minus 40 kilonewton, right, is equal to 0. Therefore, RA reaction can be determined as RA is equal to 80 divided by 4. So that means 20 kilonewton at this support. So here 20 kilonewton at this support. So totally you have how much load, downward load of 10 plus 20, 30 kilonewton. Here 20 kilonewton right reaction is there. That means we can find the other support reaction. What is that? Here RB we have determined, and 20 kilonewton here. RE is equal to, right, 30 minus 20, that is 10 kilonewton. So 10 kilonewton is acting at this point for the reaction. Here 20 kilonewton. So totally if you're adding sigma v equal to 0 due to the external load, right? So downward load is minus 30 and the reaction is totally plus 30. So 30 minus 30 equal to 0. So it's satisfied. So that is the reaction body for this. Now how will you find the reaction for this single overhanging beam? Reaction already found out 20 kilonewton, 20 kilonewton and 10 kilonewton. The shear force. So shear force at C, that is the overhanging point is, so I am taking right side or left side only this load. So it is downward, left downward is minus 10 kilonewton. Then to the left of A again the reaction is there, left of A again minus 10 kilonewton. To the right of A, if you are taking a section, minus 10 plus 10, what will happen? It will be 0 here. So here minus 10, here it will be 0. Then coming to the at the support B, what will happen? I am taking right side. So here 20 kilonewton upward, again it is minus 20 kilonewton. So here minus 10, then 0. Here you have what happened? Minus 20 kilonewton. So if you are drawing the diagram of shear force, so minus 10 you have to plot. Minus means horizontal line, right? Minus 10 up to the left it will be constant, right? 10 kilonewton, then it reaches to 0. Then after that what will happen? To the right of B, right? So it is plus 10 kilonewton, because why? We are taking right side, what will happen? This 20 kilonewton plays into a vital role, right? Plus 20 minus 10, it is plus. So again it will reaches plus value plus 10, then it will reaches minus value of 20 kilonewton. That means a triangle, right? So you are getting right here constant value of 10 kilonewton. Here it reaches to plus 10, then it reaches to minus 10. It is a triangle for the shear force diagram, right? The maximum shear force occurs at the right support, which is of 20 kilonewton. So this is how we have to find the shear force diagram. In the next video, we can go for the bending moment diagram for the same type of beam, one side overhanging beam, which is a left side overhanging beam, which is subject to point load at C and UDL for the portion A and B. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.